Welcome to our ISMA talk on the paper evaluation of text selection techniques in VR HMDs. So I'm Wenger from the Birmingham City University, and this work is done with my colleague Shenru Kangyu Haining from Xi'an Jiao Tongli Foreign University and Xian from Birmingham City University. Today's VR HMDs enable users to chat with friends, watch movies, watch TV shows, browse newspapers, and even work in a virtual office. So these activities involve selecting text fragments frequently. For instance, we use text selection to share information across applications, to chat with friends. We use it to search a movie review. We use it to make notes while reading academic papers, or simply for test editing. There has been some work in AR using external tracking devices. However, these methods are not suitable for VR because these external devices are not visible for VR users. They might require a flat surface to operate on, which is not accessible or natural to VR users. And this literature uses a smartphone as a dedicated input device, which is impractical for the VR HMDs and may not lead to a good performance and usability. So these are the techniques we have evaluated. The first one is controller click. The user use controller-based pointing to move the cursor and then click the controller button to make the selection. The second one is head click. The user used the head rotation to move the cursor and click on the controller to make the selection. The third one is hand pinch. The user moved the cursor, used the hand, and then perform a pinch to make the selection. The fourth one is the controller do well. The user use controller-based pointing and do well for 1 second to make the selection. The fifth one is head do well. The user use head rotation to move the cursor, do well for 1 second to make the selection. The last one is hand do well. The user use hand movement to move the cursor and then perform do well to make the selection. So this is the testbed environment we have developed. We developed this using Unity 3D. So there are two panels, one instruction panel and one interaction panel. Instruction panel, and this is the interaction panel. For instruction panel, we use it to show what are the text to be selected. An interaction panel that is used for the user to make the selection. And we also provided two buttons. One delete button to delete the selection, one next button when the user finished the current selection, and then they can click it to proceed to the next selection. Parameters such as length of the materials, reading distance, font style, angular font size are all based on the literature, and we have adjusted accordingly with 5 pilot users. In terms of the user study, we have recruited 24 participants, 12 male, 12 female, aged between 18 and 30, with a mean age of 21 years old. Regarding their experience, 17 had experience with VR, 3 are regular users. The device we used is Oculus Quest 2. We designed the study in a one-way within subject design with the interaction technique as the within subjects variable. The techniques we evaluated are controller do well, controller click, hand do well, hand pinch, head do well, head click. For each condition, they need to complete 3 training trials, 1 for each sentence length. And on the image here, you can see 3 different sentence lengths. A single word, that is a short. Medium, that is the text fragment across 2 to 3 lines. And then for the long, that's the text across 6 to 8 lines. The user need to complete 27 experimental jobs, 9 for each sentence length, and this order is being randomized. The interaction technique was also counterbalanced. We have collected the task completion time. This is the time from when the cursor first hovers over the first target letter to the time they complete the correct selection. For total error rate, that's the total number of the wrong sentences plus the total number of deletions divided by the total number of attempts. And for not correct error rates, that's total number of wrong sentences divided by the total number of attempts. For subjective data, we have collected user experience using the user experience questionnaire workload using the NASA TLX. At the end of the study, the user need to rank the techniques, and then they have to comment on each technique. So this is the process we used to analyze the data. For performance, if the data is normally distributed, we use two-way repeated measure ANOVA. If it's not normally distributed, we process it using the ART and then do the ANOVA. For experience data, if the data is normally distributed, we use one-way repeated measure ANOVA. If it's not, we use Friedman test. In the presentation, we only report post hoc results here. So for full information, please refer to our paper. Regarding the performance data, for task completion time, we found controller click outperformed all other techniques. For head click, it outperformed all techniques except controller click. Controller D also outperformed hand do well, hand pinch, head do well. Regarding sentence length, we found participants finished the selection much faster in short than the medium and long. We found participants finish it much faster in medium than the long condition. For total error rate, controller click outperformed hand pinch. Controller do well, head click, head do well, all outperformed controller click, hand do well, and hand pinch. Regarding user preference, we only report the average value, average significance results here. For subscales, please refer to our paper. For UEQ, the average score, we found head click had a higher average score than the hand do well, hand pinch, controller do well. We found controller click had higher average UEQ score than the hand do well and hand pinch. For NASA TLX, the overall score, user experienced more workload in hand pinch than all other techniques except hand do well. Users experience more workload in hand do well than controller click and head click. As for ranking, head click was preferred, followed by controller click. For bare hand interactions such as the hand do well, hand pinch were least preferred. So here are some recommendations. If a controller is available, when the performance is desired, we recommend using head click. If rapid neck movement is an issue, then we recommend controller do well and also controller click. When user preference is preferred, we recommend head click and also controller click. If a good user experience is preferred, then we recommend head click. If a low workload is preferred, then the user should use controller click. If a controller is not available, the device-free and hands-free technique head do well should be used. Bare hand interactions such as the hand do well, hand pinch should be minimized due to their poor performance and also their poor experience. We do have several limitations, and we have also used this limitation to point our direction for the future work. In our study, we have focused on the user-driven text selection. That means the user need to select the text while moving it to make the selection. For desktop, there are certain techniques that is called auto text selection. So, for instance, if the user double clicks on the word and then in desktop applications, it will allow the user to select the word. If they click it triple times, then they should select the whole paragraph. So this is something we can explore in the future. And currently, we only focus on the out of reach task selection because we assume our condition is in a reading task condition. In the future, we can explore these studies in arm reach, and the techniques will be very different. Currently, we only focus on single hand interaction. For instance, user need to use the SIM controller to point the text and also to make the selection. In the future, we can use one controller to point to the text location and then use the other controller to confirm the selection. Same applies for the hands. User can use two hands for the selection. This will be part of our future work. Thank you for watching this in the presentation. So any questions?